Today's lecture is to find out the number of gametes from any genotype. That is how to calculate the number of gametes from a given genotype. The formula is number of gametes equal to 2 is the power n. Why 2? Because in a diploid organism, each gene consists of two sets of allele, allele 1 and allele 2, which may be dominant, homozygous dominant, या homozygous recessive, या heterozygous. Thus, the number of gamete equal to 2 is the power n. Now, n equal to number of heterozygous. This you have to keep in mind. N equal to number of heterozygous allele, number of heterozygous gene. Okay, number of heterozygous gene. So, just to start the first example, suppose if this is the genotype, so how many allele will form? You simply will say the gamete A and gamete small a. Okay, so but if the genotype is 2 dihybrid and each is present in the heterozygous condition, so it will be 2 is the power 2, that is 4. So 4 different type of gamete will be formed. Okay, 4 different type of gametes will be formed. So how these 4 different type of gametes will be formed? Very simple. You have to write for the first gene A and then a small a. So two form of same gene heterozygous. Now this two allele for a single gene B will be for each the allele of the first gene. So B, a small b, a small b, capital B, a small b. Now the gametes are A B, a small b, a small a, capital B, a small b. So 1, 2, 3, 4. So 4 gametes will be formed from dihybrid cross and both gene having heterozygous in nature. Now if I say what will be the number of gamete for this one, so what we find only one set of allele which is heterozygous in nature and this is homozygous. So 2 is a power 1. Why 1? Only one gene is heterozygous in nature. So the number of gamete will be 2. Yes, it will be 2. See, a small a. So B is only of one type, B. So AB and a small b. Okay, so you have to keep in mind the number of heterozygous gene. The third example, suppose the trihybrid cross AA. So the number of heterozygous is 1, 2 and 3. So the number of gamete will be 2 is the power 3, that is 8. See, 8 different type of gamete will be formed. First A and a small a, the allele for gene 1. Then to this allele, give the allele for gene second. Now the third, C, small c. Okay, first gene, second gene, third gene, and all the genes are heterozygous in nature. The total gametes will be 8. So how 8? And what are the different type of gametes? A, B, C. Okay, A, B, C. Then A, B, small c. A, B, small c. Now A, small b, capital C. A, small b, capital C. And this A, small b, small c. Again A, dominant B, dominant C. A, B, C. And this will be A, dominant B, small c, recessive C. A, B, small c. Similarly, A, dominant a small b, this will be a small b, and dominant C. A small b, small c. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. So 8 different type of gametes are formed out of this trihybrid cross and all alleles are in heterozygous condition. So one thing you have to keep in mind that the n equal to the number of heterozygous gene. Okay, this is very important. Even if the genes are dihybrid, but if the genes is in homozygous condition, it will be not be considered. Only the heterozygous will be considered. Once more, if I say the genotype is AA, BB, and CC, so the heterozygous is only 1 and 2. So the number of the gamete will be 2 is the power 2 equal to only 4, not 8. Though one gene is present but is homozygous. So what will be the gene? A will be only of one type because it is of only one type of allele. So A. Now B, small b. Now capital C, small c, capital C, small c. So A, B, C, A, B, small c, A, small b, capital C, A, small b, small c. So only four type of gamete will be formed because it is in homozygous condition. This lecture is very important because you have to always ask in the any examination that how to find out the number of gametes from a given genotype. Okay.